Hey guys, welcome back to Math Principles. Last time we were together, we were talking about simplifying square roots. And before that, we were talking about a bunch of different ways to solve quadratic equations. Well, now we're going to put those two together. Okay, we're going to solve quadratics using square roots. Now, if we keep in mind, a quadratic is any equation that looks like this guy, ax squared plus bx plus c. Usually we get that equal to 0 before we do anything else with it. Okay, now here's the catch though. This is the simplest way to solve a quadratic equation. Okay, the catch is it can only be used when b equals 0. So what that means is we're going to see an equation where we just have the ax squared term and the constant term. We don't have a second x. Now, if that happens, we can use this approach. All we have to do is use inverse operations in reverse order of operations to get that x by itself. Okay, that's really all there is to it. So we just go right after that x. So let's take a look at a couple of these examples. Is first off, I have x squared plus 11 equals 36. So the first thing that I'm going to do is subtract that 11 from both sides. Okay, x is being squared, and then they're adding 11. So I work backwards, I subtract that 11, and I'll have x squared equals 25. It looks like 26. There we go. Okay, now, the square root, we talked about this last session. This is just the inverse of squaring. So on the left side, the squared and square root are going to cancel, and I'll just have x all by itself. And on the right side, I'll just have 5. Now keep in mind, it's got to be plus or minus 5, because the square root can be positive or negative. Okay, there we go. All right, let's take a look at the next one. X squared minus 4 equals 12. Now, once again, there is no bx term here. We just have the x squared term and the constant term, and that's it. Okay, so that x is being squared, they're subtracting 4, so we'll start by adding 4 to both sides of this equation. On the left side, adding 4, subtracting 4 cancels, and I'll just have x squared. On the right side, 12 plus 4 is going to be 16. Okay, now x is just being squared, so I take the square root on each side. Squared and square root cancel. X is all by itself, and on the right side, I have plus or minus 4. And there we go. Okay, let's level up just a little bit here. I've got 2x squared plus 11 equals 139. Okay, don't let those big numbers scare you. It's not a big deal. Okay, because we're just going to subtract 11 from both sides. And we'll have 2x squared equals 128. Then we'll divide both sides by 2. And we'll have x squared equals 64. And then we'll take the square root on each side. And on the left side, squared and square root cancel. On the right side, I'll have plus or minus 8. So x equals plus or minus 8. And there we go. All right, example 4, we've got the dreaded fraction. Oh my goodness, it's going to be 5. Okay, just relax. Do the same thing as we always do. We see x is being squared. It's being multiplied by a half. And then they're subtracting 18. So we just work backwards. We'll start by adding 18 to both sides. Okay, on the left side, those cancel, and I'll just have 1/2 times x squared. And on the right side, 54 plus 18 is going to be 72. Okay, now, x is being squared and then multiplied by a half. So the opposite of multiplying by a half is dividing by a half. So I should divide both sides by 1/2. Now we can do that, but there was a trick we learned back in middle school. Okay, to divide by a fraction, we multiply by the reciprocal. So the reciprocal of 1/2 would be 2 over 1. Or even more simply, just 2. Okay, now we know that if I multiply by the reciprocal, we multiply straight across. 2 times 1 would be 1. 1 times 2 would be 2. Let me try that again. 2 times 1 would be 2. 1 times 2 would also be 2. So I'd have 2 over 2 times x. Well, 2 over 2 is just 1. And 1 times x is just x. Okay, so that's the whole reason we do that. Then on the right side, 72 times 2 is 144. Okay, so sorry about that. I've got x squared equals 144 because our next move is to take the square root. on each side. Okay, on the left side, the square and square root cancel. X is all by itself. And on the right side, we've got plus or minus 12. Okay, and there we go. All right, so we did 4 of these. They were all pretty basic, just going right after that x, getting that x by itself, inverse operations, and reverse order of operations. Now, all of those worked out nice and neatly with integers, and that's how we like to start, okay, just getting our feet wet. Okay, but sometimes that's not going to happen. Sometimes it won't work out all nice and neat with integers, but that's okay. All we're going to do is simplify the roots like we did in the last session. And remember, that was a little trick. If you have the square root of a fraction, okay, all you have to do is take the square root of the numerator and square root of the denominator separately. That's it. Okay, so if that comes up, not a big deal. Don't panic. Just leave the fraction alone, square root the top, square root the bottom. All right, so now I have x squared minus 8 equals 12. So my first move, I'm going to add that 8 to both sides of the equation. Okay, on the left side, they'll cancel. Sorry, let me catch up here. On the left side, those 8's cancel, and I just have x squared. And on the right side, I have 20. Okay, so next move, take the square root on each side. Okay, left side's easy. Squared and square root cancel. X is all by itself. On the right side, 20 is not a perfect square. So I'm not going to get an integer answer here. If we remember last lesson, okay, what I want to look for are 2 square roots, one of which is a perfect square that evenly divides 20. Well, 4 is a perfect square that evenly divides 20. Okay, and 4 times 5 gives me 20. So I split that square root of 20 into the square root of 4, square root of 5. Okay, the square root of 4 is plus or minus 2. And the square root of 5, well, that's the square root of 5. We leave it alone. So I have x equals plus or minus 2 times the square root of 5. All right, moving right along. Next up, okay, I have 3x squared plus 4 equals 100. So x is being squared, multiplied by 3, added by 4. So I'll work backwards and do the opposites. Subtract 4 from each side. Okay, on the left side, those cancel, and I just have 3x squared. On the right side, 100 minus 4 is 96. Okay, next up, divide both sides by 3. Okay, left side, 3's cancel, x squared. On the right side, 96 divided by 3 is 32. All right, so next up, take the square root on each side. Squared and square root cancel. X is all by itself. On the right side, 32 is not a perfect square, so I need to split it up. So I'm going to split it up into 2 square roots, one of which is a perfect square that evenly divides 32, and the other is what that perfect square needs to be multiplied by to get 32. Well, if I look at my list of perfect squares from last session, I'll see that 16 evenly divides 32. Okay, 16 goes into 32 twice. So I take the square root of that 16, I've got plus or minus 4 times the square root of 2. And there we go. X equals plus or minus 4 square root of 2. All right, last two. Okay, 3x squared plus 20 equals negative 4. Just work backwards. Subtract that 20 from each side. Okay, so we have 3x squared equals negative 24. Okay, divide both sides by 3. And we'll get x squared equals negative 8. Okay, now we take the square root on each side. Left side's easy. Squared and square root cancel. X is all by itself. And on the right side, square root of 8. Now, 8's not a perfect square, so it's not going to have an integer root. What's more, it's negative. So first thing I'll do is I'll split this up into the square root of 8 and the square root of negative 1. Now remember, we do this because 8 can be simplified, and the square root of negative 1, we have a value for that now. Okay, so I'm going to split this up again. Okay, I'll take 8, split it into 4 and 2, because 4 is a perfect square, and 4 times 2 gives me that 8. And I'll just bring down that square root of negative 1 for right now. So now I've got square root of 4 is plus or minus 2. Square root of 2 stays the same, and the square root of -1 is I. And now the last thing that we'll do is we'll switch this around just a little bit. So I have plus or minus 2I square root of 2. Remember, we like to put those square roots. If there's any square roots left, we like to put them at the very end. All right, last one here. Okay, I've got 4x squared plus 25. So I'll start by subtracting that 25 from each side of the equation. Okay, on the left side, squared and square root, excuse me, the 25's cancel, and I just have 4x squared. On the right side, I've got negative 25. Okay, now divide both sides by 4. On the left side, those 4's cancel, and I'll just have x squared. On the right side, I'll have negative 25 over 4. That's right, we're going to leave it as that improper fraction. Okay, negative 25 over 4. And the reason we're going to do that, right here, when I go to take the square root on each side, okay, left side's easy, squared and square root cancel, x is all by itself. But over here, well, first off, I want to separate out 25/4 and the -1. So I'll take the square root of each of those. Okay, but if we remember, we said earlier, if you have to take the square root of a fraction, just take the square root of the top and take the square root of the bottom separately. Okay, so that'll give you x equals plus or minus 5/2 I. Okay, remember, I comes from that square root of -1. Okay, square root of 25 is 5, square root of 4 is 2. Don't forget the plus or minus in front of the whole thing. And that's easy. That's done. Okay, so don't worry about making those fractions into decimals. Just leave it as that improper fraction because it's probably going to make your job a whole lot easier. Okay? All right, so solving with square roots. First thing that has to happen is there has to be no bx term. B has to be equal to 0. Okay, just the x squared and then constants. It's the most direct approach because all we're going to do is use inverse operations in reverse order of operations to get that x all by itself. Okay? If you end up with a square root that doesn't have a perfect square, excuse me, you're taking the square root of a non-perfect square. All you have to do is just simplify it like we did in the last section. Find a perfect square that evenly divides that radicand, that number underneath the root. Okay? Split it up, take the square roots you can, simplify what's left. Get that plus or minus. Okay? And that's really all there is to it.